Good afternoon, this is Daniel Carmichael giving you my road construction WLAN project overview. Here's our agenda. We'll discuss the project scope, feasibility study, network needs analysis, QoS requirements, reliability and security requirements, project design and costs, network testing tools that will be needed beginning and after the project. Here's the project scope. Purpose of this project is to redesign road construction's network infrastructure to fit current demands and become 802.11 compliant. Removing the proprietary network infrastructure will allow for a wider range of vendors and will increase the ease of scalability with future growth demands. The project will look to provide a WLAN that covers the HQ and 32 branch locations. Resources will be managed from the headquarters facility and will host the data storage used by all branch offices. A feasibility study was conducted. To run through some of the bullet points, secure services. The purpose of the networks project is to securely connect 33 locations to a single network. Employees will use wireless devices such as either iPads or laptops to connect to the network and send and receive company data. Integration and updates is recommended. All proprietary equipment is replaced using 802.11 compliant hardware. Data storage needs to be configured at the headquarters location. For style information processing, all 32 sites will need WLAN access connecting laptops, iPads, sales kiosks, IP phones. Applications including mail solutions and sales applications will need to be established. Collaboration. The database located at the company headquarters will allow employees to access and update customer requests. These requests will be generated at the customer kiosk and send data to the headquarters server for retrieval. Scalability. With the upgrade to 802.11 compliant hardware, all systems will have the ability to migrate towards future technology as demands increase. Intended users, the use of mobile devices like iPads, laptops, and IP phones will allow all sales and construction employees the ability to send and receive data anywhere centrally located at each of the 32 sites. Signal coverage will need to cover the site offices. Design assumptions. Since the current infrastructure is not 802.11 compliant, it is assumed that all previously installed components will need to be removed. If cabling exists, it may be incorporated into the new design, but will be determined at a later point. Here you can see the network needs analysis. It's broken down by data types, data sources, speed requirements, load variation estimate. You can see our minimum users and maximum users per location. So data types, road construction will require both voice and data capability for the network. Cordless VoIP phones will be at each location to include the headquarters site. Types of data being transferred will be SQL data, MS reports, and email. Data sources. Data will be collected via customer terminals and sent to the database located at the headquarters site. All satellite sites will require read and write permissions to the database. All 32 sites will require construction managers to send construction update reports to the database as well. Other sources of data will be email and VoIP services. Number of users that will need to be supported. The network will support headquarters and 32 satellite locations. User demands at a minimum are outlined and maintain daily requirements. The network will need to accommodate the maximum users projection accounting for peak season traffic demands. Speed requirements. All locations will run on 5 GHz for employee functions and 2.4 GHz for guest access. The goal for all locations is to maintain speeds of 100 gigabytes per second. Load variance estimate. Load balancing middleware will be implemented to maximize network performance. Additionally, a controller-based architect will be implemented with the adoption of PoE devices for network integration. Road construction is looking to implement a VoIP infrastructure that supports 2 phones at 32 different satellite locations and up to 100 phones at the headquarters site. A site evaluation will need to be conducted to assess how to best achieve coverage for each site. Each location will only require the phone use in the office and headquarters will need coverage between multiple floors. Designing the network, the headquarters location will require multiple access points using non-overlapping channels. This will ensure a smooth handoff, reducing drop connections when moving between access points. Additionally, monitoring the power output of each access point will ensure that co-channel interference is minimized. To achieve roaming capabilities, it will be recommended that VLANs are established to handle different types of data. The separation of traffic will allow for different levels of quality of service to be established and prioritized on each VLAN. IP phones will require connection to application servers located at headquarters site. These applications include XML services, voicemail, messaging. While the plan is to have a VOWLAN segregated into VLANs, quality of service priorities should be established separately for each type of application. Those requiring less bandwidth, with such as messaging apps, should be set to a lower priority over voice data on the network. Determining proper prioritization will be crucial to ensure that all data is received in a timely manner. If packets are unable to be transferred, it will make the benefits of the voice WLAN network obsolete. Reliability and security requirements. The network will provide coverage for central location and 32 branch locations. All sites will have access to Wi-Fi as primary source of connection. Branch access will be managed by the headquarters wireless LAN controller. 2 wireless LAN controllers will be used as a method of redundancy. Policies will be implemented to highlight how to establish and maintain network security. Security concerns and factors used to mitigate threats are as follows. Physical security. All networking equipment will be secured in locked areas that the public does not have access to. All access points will be located above ceiling tiles as to not attract attention to the locations. Encryption. VPNs will be used to sign into the network directly by home users or construction teams using public Wi-Fi. All of the locations will use WPA2 encryption. Authentication. Authentication servers will be located at the branch headquarters and use EAP transport layer security. Certificates will be managed through third party. Rogue access points. Wireless LAN controllers will be set to acknowledge newly attached access points and perform scan to maintain the status of current lightweight access points. BYOD devices. Policies will be established stating what applications are acceptable to be used on the network and will include password policies. If BYOD is preferred by an employee, mobile management software will be installed and will allow IT managers to access to backup files, perform vulnerability scans, maintain antivirus and other updates, wipe stolen lost devices remotely, and enforce security policies. Security requirements according to the Federal Information Processing Standards. AES must be used for government organizations that protect sensitive and unclassified information. As you can see here, highlighted is a single branch office location, showing that the IP phones are segregated to their own VLAN. You have the access point for the office and then a access point for guests. All 32 locations should be similar to this. To the right, top right, you see the headquarters location. Represented there are the databases that each location will have access to. And then right below that is a packet tracer diagram of our projected network. Here's a snapshot of our project costs. Total investment is just over $2 million. Costs associated include hardware, training, installation, and there is a contingency buffer. These costs are broken down further in our design documentation. Specific WLAN testing tools should be used during all stages of employment, including design, employment, and maintenance/troubleshooting of the network. 3 common categories of testing tools are spectrum analyzers, signal coverage tester, and wireless protocol analyzers. Spectrum analyzers are used to assess radio signal interference. The spectrum analyzer is used to see RF signal power and determine if interference is needed to be addressed. We'll use these tools to ensure that the antenna propagation is correct for the placement of access points. Another tool, the signal coverage tester, designed to measure the signal strength and signal to noise ratio of access points. This allows us to identify the current signals and make any access point adjustments needed to achieve desired signal reception. Many of these tools allow for the incorporation of blueprints and heat maps that depict the results of the signal. The last tool is a wireless protocol analyzer. They capture 802.11 signals and decodes applicable frames. A common tool is Wireshark. By using tools like this, users can capture and analyze sent packets to see whether they can identify and isolate causes of network traffic issues. All of these tools will be incorporated into the design, employment, and testing of our network. This concludes my brief. Please see the attached design document for any further questions.